Lesson 11C, we are learning about the triangle inequality. You're going to be constructing triangles given three sides. And we're going to talk about the conditions that must occur to make triangles. So far we've talked about, in the past lesson, we reviewed all the different ways to name and classify a triangle. Do you remember all of them? Okay. So you can name them by the angles, you can name them by the sides. The first thing I want you to do today is in that blank space on the left side of your notes, use your ruler and draw a triangle the best you can with the side lengths of 3 centimeters, 5 centimeters, and 11 centimeters. Your ruler, if you forgot which side is the centimeter, it's labeled with CM. It's the side that has the numbers closer together. So, a lot of you are saying things like, it's too long, it's too short, the 11 is sticking out, things like that, right? It is impossible, you're right. This doesn't make a triangle because, I'll show you, it looks like this. Close it. What were the sides?
3, 5, 11.
Thank you. 3, 5, and 11. Clearly, this one right here is like way too long to make a triangle, right? You are probably intersecting and it cuts off and it sticks out, right? It doesn't make a triangle. So go ahead and just write yourself a note there. It doesn't make a triangle. And I want you to think about this. Just because you have 3 different side lengths doesn't mean you can just put them together to make a triangle, as you just saw. Sometimes it won't make a triangle. So I want you to use the straws in your baggie there, you and your partner share, and try to make this triangle. 2 centimeters, 3 centimeters, 2 centimeters. And I already measured and pre-cut those straws for you. So you're going to use your ruler to figure out which straw is 2 centimeters, which one is 3 centimeters, and so on. And try to make a triangle. This one does make a triangle. And what do you call that triangle? What's it named? What kind of triangle is it? Isosceles. Please write this on your notes. Yes, you can make a triangle. You can go ahead and sketch it on your paper as well so that you remember what you made with the straws. And then write that it was an isosceles triangle because 2 of the sides were the same. They're both 2 centimeters. You should have had something that looked like this. 2, 3, and 3, right? I mean 2, 2, and 3. So it should have made a triangle. Yours might be sideways, upside down. It's still the same triangle. Go ahead and try number 2. Make a triangle with the side lengths 4, 4, and 4. This does make a triangle. What is this triangle called? Equilateral. Go ahead and sketch it and then write equilateral on your notes. It should look like this. 4, 4, and 4. And 4. There you go. Your triangle should look like an equilateral triangle. Let's do one more. Make a triangle that has 6, 2, and 3. You're right. This one does not make a triangle, so you can't name it because it's not a triangle. Now, this doesn't make a triangle because of reasons we're going to discuss today. That was the objective of this lesson. Your paper probably looked like this, 6, 2, and 3. Here's my 6. Here's my 2. And my 3. This has 2 legs that are too short to meet to make a triangle, right? Doesn't quite reach. So let's talk about this. We are going to spend the next few minutes, turn your notes over, doing this activity with your partner. You're going to create all of those triangles in the table. Write yes or no to see if it does make a triangle or not. And see if you can draw a conjecture that tells you about the relationship between the sum of the small and medium sides of the triangle and the measure of the large side of the triangle. Go ahead and do that whole page there. From that activity, you discovered what we call the triangle inequality. That says that the sum of the two sides of the triangle has to be greater than the third side, the largest side. So small plus medium is greater than the large. For example, 3 inches, 5 inches, 6 inches. The two small and medium ones are the 3 and the 5. 3 plus 5 is 8. Is 8 bigger than 6?
Yeah.
Yes, that makes a triangle. 7, 8, 11. 7 plus 8 is 15. Is that bigger than 11? Yes, that would make a triangle. And then anything that would not make a triangle would look like this. 3, 2, and 6. 3 and 2 are the shorter ones. That will make 5. Is 5 bigger than 6? That doesn't make a triangle. 7, 8, and 16. 7 and 8 are the short ones. That would make 15. Is 15 bigger than 16? Nope, that would not make a triangle. And also, if it equals the third side, it would also not make a triangle. 1, 1, and 2. It's not equal. I mean, it has to be greater than. If it's equal, it still would not make a triangle. And let me show you what that looks like. If I have my 2 here, and the other one is 1 and 1. These are too short because what we want at the top of the triangle is for them to be long enough to touch, right? These actually drop exactly down to make that bottom line. If it lies flat, that's not a triangle, it's a line. Do you see that? We want it to be long enough to hit, not exactly 2. We want it to be longer than 2. So the triangle inequality, just a little history blurb here, it's proven to be true in 300 BC by a Greek mathematician named Euclid. And he's usually referred to as the father of geometry, and this tablet you're looking at here is where he wrote a lot of his theorems. He proved a lot of theorems on there. So we're going to end our lesson with naming our triangles. So if it can be a triangle, I want you to tell me what kind of triangle. And to know if it is a triangle or not, you have to use the theorem, the inequality. So this first one, 5, 12, 13 inches. Does that make a triangle? How do you know? Because 5 plus 12 is bigger than 13. So what kind of triangle would that make? Scaling. Good. They're all 3 different lengths. How about this one? 4, 9, 4. The 2 short ones are which ones? 4 and 4. Don't just add the first 2 numbers. Remember, it has to be small plus medium. So 4 plus 4 is 8. Is that bigger than 9? No. So this doesn't make a triangle. Don't get fooled. The next one. Does this make a triangle? Add the 2 small ones. Yes, that would make 6.10 or 6.1, which is a lot bigger than 3.5. What kind of triangle is this? Isosceles. 2 of the sides are the same. And this one? Yeah. Equilateral. Very good. And one more. 3, 11, and 6. The 2 small ones would be the 3 and the 6, which makes 9, which is not bigger than 11, so this doesn't make a triangle. Any questions? All right, number 1s, it's your turn today. What did you learn? Ready? Share.
Okay.